Started. So over the Thanksgiving break, I think on Monday there's going to be an announcement that posts to our class page on My Notre Dame. On that announcement, it's going to be titled like end of semester survey or something to that effect. On that announcement is going to have a link to a Google Sheet that I'd like you to fill out. It's going to ask you whether you want to take a doubled high test score or to retake a chapter test. And if you are electing to do the retake, like what test and when would you like to do that? The chapter 5 test that we just finished was our last test for the semester. So you have all the information you need to kind of make a decision about what you want to do. I'd ask that at some point during your break that you kind of figure that out so that I can have time to get retake tests made up into the right places for those of you that are electing to do that. Okay. Any questions about that?
Are you allowed to use a note card on your retake?
No. Good question, though. What is next? We finished chapter 5. We're continuing to do stuff. We're going to start chapter 7. Anything we do from chapter 7 between now and the final exam will be exam-only material. We will not have another test. We will continue to have homework assignments. We'll probably still have another homework quiz from chapter 7. But there will not be a chapter 7 test. Everybody's okay with that idea? Okay. So the Friday that we get back from break, that Friday that we're back from break is going to be the deadline for any late or missing homeworks on chapters 2 through 5. So if you have late or missing or incomplete or whatever things for those, anything up through chapter 5, your deadline for me to accept anything for any kind of points is going to be that last Friday or the Friday after we come back from break. Okay, after that, I would still accept late things from chapter 7, but 2 through 5 is no bueno anymore. Okay? So if you got a stack of missings that you're like, oh, I was going to catch up on those someday, Friday's got to be that someday. Okay? So if that's you, take some time over break and get as caught up as you possibly can as we ready for ourselves for that sprint to the finish. Any questions about any of those things there? All sound pretty fair. Nice to hear no test till the final. That's good. We got it crammed in this week. That was probably better for everybody. All right. So today we're going to be looking at chapter 7, or starting chapter 7. And chapter 7 marks a little bit of a return back to geometry. So we had gotten pretty far away from the geometric side of trigonometry. We're going to kind of circle back into some geometric-oriented topics now that we've really kind of gone fairly deep into dealing with sine, cosine, tangent, etc., or trigonometric functions. So recall from geometry that if I have some right triangle and I ask you to solve that triangle, the main tool that we're going to use is going to be SOHCAHTOA, right? Now you might also use the Pythagorean theorem, or that there's 180 degrees in a triangle. Those are fine, that's valid. You'll would probably use those as well, but our main tool would be SOHCAHTOA. What happens for a non-right triangle? You know, something like this. Can I still use SOHCAHTOA? You cannot. What we're going to be doing in Chapter 7 is developing tools that we can use on non-right triangles. Okay? So to deal with solve the triangle when the triangle's a non-right triangle, or to find the area if the triangle's a non-right triangle. So that's going to be our major point of emphasis here. Now, it turns out we can't use SOHCAHTOA. We can't use the Pythagorean theorem. What tools are we going to get? Well, there's two primary tools that we'll have to use. One of those is called the law of sines, and the other is called the law of cosines. Those will be our two primary tools for solving non-right triangles. And we'll talk here over in the next couple of days about the how to use them. But before we do that, I want to start by talking about the when to use them. So how do I know which formula I need to use? Should I be using law of sines or should I be using law of cosines? That's where I want to start our discussion. Everybody's okay? And again, I'm going to abbreviate law of sines as LOS and law of cosines as LOC because I'm going to say those things, I'll write those things a lot. I don't want to have to, it's a lot of letters, you know? So the way that we're going to decide which formula to use in a given situation is we're going to use the same criteria that we use to prove triangle congruence back in geometry. Remember, you had 5 triangle congruence theorems. Usually they had 3-letter abbreviations. Does anybody remember any of those names? Lucy?
Side.
So side angle side is one of them. So let's talk about how I can look at a triangle and tell which situation I'm in. So if we're talking about side angle side, means we know one of the angles, and we know 2 of the sides, and the sides that we know have to make the angle that we know. So everybody can kind of see the picture there and identify. Now, the congruence theorem that was most similar to this, you guys called the hypotenuse leg theorem, I think, in your textbook. This was, in geometry, a special case of the SSA situation. Remember, there's no SSA theorem. We'll talk more about why. but this is a special SSA case where the angle has to be a 90-degree angle. For us, we're going to be dealing with an SSA situation. Now, it's easy to confuse the side angle side and the SSA because they both involve two sides and an angle, right? So the difference between them, when I look at the picture, what is the difference? Notice in the SSA case, one of the sides that we're given is not part of the angle, right? In the SSA case, the two sides have to make the angle. In the SSA case, one of the sides is not part of the angle. So you guys all feel confident you can look at a picture and decide, tell the difference between the two? Okay, it's going to be really important that we're able to do that. If you're not able to choose the correct tool, it's unlikely we're able to do anything after that point. That's really the very beginning of the problem. Well, actually, there's one step in front of that even, but it's very early on in the problem. We can't even get to the right, if we can't get to the right tool, we're in trouble. You know what I mean? Okay. Does anybody else remember another one? Angle. Angle, side angle is one of them, absolutely. So what is that one going to look like? So we have an angle. We have another angle. And then the given side has to be part of both angles. You see how the green side that's given makes up both part of the blue angle and the orange angle, right? That's our key for angle, side angle. What's the other situation that's going to be similar, most similar to this one and likely to get confused? Angle, angle, side. So let's kind of draw this one. We'll color code this one as well. So again, we have an angle. Then we have another angle. Oops, I forgot to color code. And now our side is going to be the side that's not part of both angles. So it could be here or it could be here. It doesn't really matter. It's just as long as that side isn't part of both angles. So that's the other pair that's easy to confuse. Again, because they both have two angles and one side. The previous two had two sides and one angle. Got to make sure we can tell the difference between them. Our fifth and final triangle congruence theorem was? What do you guys think? Does anybody remember it? Lucy, what'd you say? What? We already did side-side angle. That was the hypotenuse leg was the special case of side-side. We already did side angle side. That was the first one we listed. What do you guys think? Nope. Side angle would be the same as angle side, right? It's side, side. Yeah. That's the last one. And nobody can possibly confuse this with any of the others because, well, it's the only one that has just 3 sides in it, right? It's like the easiest one to pick out. Nobody ever messes that one up. Somebody in here is thinking, Mr. Kulik, challenge accepted. I will be the first one, don't worry. And oh, please don't. All right. What do you guys think so far? Do you feel confident that you can pick out the situation based on the picture? Okay. So this is the when, right? The when we should use these. Let's talk about the what of them. What is the law of sines or the law of cosines? We're going to start with that today, with just the law of sines. Now, the formula that we're going to use for the law of sines depends on the picture. If you're not able to draw and label the picture using the method that I'm going to describe to you right now, you will not get the numbers in the right spots in your formula. You will not get the right answers. Everything will be wrong because you can't draw and label a picture effectively. So let's talk about how we need to do this. Okay? So I'm going to just draw for myself like a generic old triangle. So when we draw our triangle, the first thing we want to do is label the angles. We're going to label the angles with capital letters. I'm going to start on the left and name my angles in a clockwise fashion. So I'll start with A, then B, then C. Always using capital letters for angles. So far, so good. Now, the names for my sides are going to be based on the angle. So if I look at angle A, I'm going to look at the side opposite angle A. That's the side BC. I'm going to name the side BC using the lowercase letter a. So whatever the angle is opposite the side, I'm going to use the lowercase version of that same letter. So if I'm looking at angle B, the side opposite angle B is the side AC. I'm going to name that side with the lowercase letter b. And finally, for angle C, the side opposite angle C is the side AB. I'm going to name that side with the lowercase letter c. Is everybody okay with this naming convention? Critically important that you're able to name your triangle using this convention because the formulas are based on you naming the triangle that way. If you don't do that, you're going to end up putting the wrong numbers in the wrong places and getting all the wrong answers, and it's going to be a big bloody mess. Everybody's okay? All right. So I have a question now for you guys that I'd like, and this is not a hypothetical question, this is a question I honestly want your answer, and there's no wrong answer to this. Would you rather I show you how we end up with the equation for the law of sines, or do you just want me to tell it to you and you'll accept it as this is the formula? Do you want to see where the formula comes from, or do you just want the formula and to go? Just the formula? Okay. So our statement for the law of sines then is sine of angle A over side A equals the sine of angle B over side B, which equals the sine of angle C over side C. Now, when I look at this equation is really three formulas built in. When I use the law of sines in practice, I'm only going to be using part of this equation on any given step. So I could use this part, sine of angle A over A is equal to sine of angle B over B. Or I could use this part, sine of angle B over side B equals sine of angle C over side C. Or I could use this part, sine of angle A over side A equals sine of angle C over side C. See how there's like three formulas built into one equation here? All right, so that's the law of sines. Let's do some examples now, practicing using it to solve some triangles. You guys feel so far so good? Okay. So our first example says, in a triangle, angle A is 32 degrees, angle B is 73 degrees, and side C is 13 inches. Solve the triangle. Notice that I can tell immediately what's an angle versus a side based on the unit attached to the number, right? The 32 has a degree symbol, so I know that A is an angle. The B has a degree symbol, I know that's an angle. The C has inches, I know that's a side. Everybody's okay? So before I do anything else, I need to draw a picture of my situation. So again, I'm going to name the angles of my triangle with capital letters A, B, and C. Now I'm going to ask you guys, should I name which side of this triangle should I name as lowercase letter a? Should I call that AB, BC, or AC? BC. Very good. Which side should be little b? AC. And then obviously then AB is going to be little c. Everybody feel okay here? I'm now going to write in the given information. So angle A is 32 degrees. Angle B is 73 degrees. And side C is 13. So now what I'll do is I'll determine which situation I'm in. So there's angle B. There's angle A. And there's side C. Which situation is this? Angle, side, angle. Very good. And that tells me that I need to be doing the law of sines. Everybody follow so far? The directions say solve the triangle. What does solve the triangle mean? What is that direction telling us to do? Find all the missing angles and side lengths, right? So I'm going to make a list of the things I need to find. So I need to find angle C, need to find side A, and side B. So far, so good. Now, yes, Colby.
I don't know if you're using law of sine or law of cosine.
So we went back and, oh my gosh, did I not write this down? Well, poop on me. Let's take a little sidetrack here. Thank you. Law of sines is these three situations. I'm going to put a little asterisk by side angle because that's a special situation that's going to need like its own day dedicated to dealing with. Law of cosines is going to be side angle side and side side. And I'm going to put a little, different asterisk on those ones because there the order in what we're doing matters. So I'm just going to make it a little bit different. It's law of cosine still, but the order in which we're doing things matters. So far, so good. Colby, is that?
Yeah.
Okay. Yeah, that's my bad for not having that written that before. Thank you for asking. I would have forgotten. All right, so back to our problem now. So notice from our given information, we have two angles, right? If I have two angles in a triangle, I can always find the third basically for free. I don't have much to do to find that third angle. How do I find that third angle? It's not the Pythagorean theorem. That Pythagorean theorem is for side lengths, and it only works for right triangles. Yeah, I know there's 180 degrees in a triangle. So that third angle should be 180 minus my two given angles. So whenever I have two of the three angles, I stop and find the third one for free, no matter where I'm at in the problem. If it's at the start, let me do it at the start. If it's at the end, I'll do it at the end. But I'm never going to calculate a third angle in any triangle problem using a formula. I'm just going to 180 minus the other two. So far, so good? Now, we still need to find side A and side B. For the ASA and AAS cases, the order in which you solve for side lengths does not matter. In fact, anytime you're solving for side lengths, the order does not matter. So I'm going to choose to solve for angle A, side A first. So if I go back and I look at my law of sines, do I want to use the stuff that I circled in blue to solve for little a, or the stuff I circled in yellow? Why blue? That's the correct answer.
Because you're looking for
So I need to have the piece that I'm using, I need to know both the angle C and side, or the angle and the side. The only pair that I have that for is C. So whatever I'm trying to solve for needs to have sine C over side C in it. Does that make sense to you guys? The only letter that I know both the angle and the side for right now is C. So I'll write sine of angle C over side C equals sine of angle A over side A. So that's the equation that I have now. What's the name for this type of an equation where I have one fraction equal to another fraction? Do you remember from geometry? You would have used this word a bunch of times probably. Starts with a P. It is a proportion. Very good. What is the technique we use to solve a proportion called? What we use to solve a proportion, we call it cross multiply. Cross multiplication is a solving technique to solve a proportion. It is not an operation on fractions. It's a solving technique for a proportion. I'm going to say cross multiply a bunch of times this chapter. Don't confuse it with an operation on fractions. There's no time where you multiply two fractions together and you do anything that says cross multiply. This is a solving technique. Everybody's okay? So I'll have A times sine 75 equals 13 times sine 32. What do I need to solve my new equation now? What do I need to do to get A by itself? Exactly right. We'll divide both sides by sine 75. And at this point, it's now calculator time. So before I start this problem, what should I check on my calculator? I need to be in degree mode. How did you know I needed to be in degree mode? Because the angles are all in degrees. Very good. So mine is already in degree mode. The good news is this entire chapter you're going to be in degree mode, so it won't be like chapter 4 where you had to change back and forth. So when I type this in, I get 7.13. Everybody so far so good? Okay. Let's now solve for side B. Now, if we look, now that we've solved for side A, we now know both the side and the angle for A and for C. You guys agree? Which one should I use, though? I should still use C. Why? There's two really decent reasons to make that choice. Okay, great. So one reason is that our answer for side A was something that we rounded. So if I use a rounded answer to get another answer and have to round again, that's like 2 layers of rounding in that one problem. Now, for what we're doing, you're still going to get the right answer. It won't make a bunch of a difference. But if you work for NASA and you're trying to land a rocket on the moon, you need as much accuracy as you can, because if you're off by like the 5th decimal place, you might miss the moon entirely, and then you've wasted like couple $100 million and probably are going to get fired. So that's one good reason. The second is like a practical reason, Lucy.
Like if you get side A wrong, you get B right.
Exactly right. If my answer for side A is wrong, and I use that wrong number in another calculation, the resulting calculation is going to be wrong, and I don't want that to happen. I'm positive that angle C and side C are correct because they were given to me. So if I have the choice, I'm always going to use givens over things that I had to solve for myself. So I'll say sine C over side C equals sine B over side B. So far, so good. What's this kind of an equation called again? Proportion. And how do I solve it? Cross multiply. That's right. So I'll have B times sine 75 equals 13 times sine 73. And then to get the B by itself, what do I need to do? Divide by sine 75. Very good. And then it's calculator time. So I get about 12.87. Yes, sir? Sure. All right. I want to show you guys a little check that we can do at the end just to make sure that we have a feasible answer. Okay? The check I'm about to show you is not a 100% check. We don't know that our answer will be right. But this check will often pick up if you've made a silly mistake and you have an answer that just like this answer doesn't even possible. So if you remember back to geometry, there was a theorem that we had that said that the side lengths and angle measures for a triangle were proportional. So that means that the biggest angle should be opposite the biggest side. Our biggest angle was 13. I'm sorry, biggest angle was 75 and our biggest side was 13. Those are opposite each other. And then our middle angle should be opposite our medium angle should be opposite our medium side. 73 was our medium angle. 12.87 was our medium side. And then our smallest angle should be opposite our smallest side. 32 was our smallest angle. And 7.13 was our smallest side. So that all looks pretty good. Now that's not a 100% check, but if you do something silly like write your answer for A where B should be or something like that, it should catch those. So it's always a good thing to just go back and double check. Or if you plugged a number into the wrong spot, probably you'll catch it. Everybody's okay? One more example. Yes. Sure. Say hi to the bathroom party. Okay. All right. Next example, says in a triangle, if angle P is 43 degrees, angle Q is 80 degrees, and side Q is 7.3 centimeters, solve the triangle. Well, we start by drawing a picture. And then we'll label. So P, Q. Oh no, what should the third letter be? R. Why R? It's the next letter in the alphabet, right? But Mr. Kulik, what if I want to do O? That's the one before P. I mean, God bless you, but you know what I hate as a letter for a variable? O. Do you know why? It looks like 0, man. I don't want to use anything that looks like a number. Get the heck out of here. Terrible choice. Everybody's okay? All right, let's label the sides now. So P, Q, and R. We'll fill in our knowns. And now let's look at the situation. What situation do we end in? What do we have here? Angle, angle, side is correct. Thanks, Whispers. Which again tells me that we should be doing law of sines. So I'll make a list of the things I need to solve for. That'd be angle R, side R, and then side P. Is everybody so far so good? What should I solve for first? Angle R. How do I do that? Yeah, so 180 minus 80 minus 43. That's 57, so I'll add that to my picture. What's up?
I have a question.
Sure, what's up?
I can come back later.
It's okay.
First. It says in terms of sines and cosines, am I only allowed to use sines and cosines in my final answer?
Yes.
Okay. Thank you.
Yes. All right. Which letter do you want to solve for first, P or R? Does it matter? It doesn't matter. So let's just pick one. Which one do you want to pick? Okay. So which letter am I going to use with R? P or Q? Q. Very good. Why? Because it's the only one I know both the angle and the side for, right? So write sine of angle Q over side Q equals sine of angle R over side R. There's our, what's that equation called? Proportion. Okay, and to solve that proportion, what do? Cross multiply. Can I do the cross multiply and divide all in one step? Everybody's okay with that? Okay. Just in the interest of like consolidating. If you are comfortable doing all that work in one step, you're welcome to do that as well. If you're not, go ahead and take more than one, no big deal. So we get about 6.22. And I think that was centimeters was the unit in this problem. And now we'll solve for P. Hey, just as an aside here, why can't I just use the Pythagorean theorem now that I have two of the three sides? Why? It's not a right triangle. Very good. Yeah, that is a requirement for the Pythagorean theorem, is it's a right triangle. All right, to solve for P, what other letter am I going to use to solve for side P? Q or R? Q, just because I don't want to use an answer I came up with, I'd rather use the givens. Sure. Say hi to everybody else. So we'll cross multiply and divide to solve our proportion. And I get about 506. Then if I do our check, is my biggest angle and biggest side match up? 80 and 7.3? Yup.
Yeah.
Does our medium side and medium angle match up?
Yeah.
Yup. And small? Yup. Look good to you guys? Yup. All right. That's enough for today.
Please use the restroom.
Yeah. For your homework, I'd like you to work on 1 through 4. That's going to be Sunday's problem set. So this Sunday, the problem set is going to be 1 through 4. Anything we do on Friday will be due the week or the Sunday after we return from break. So nothing will be due right before you guys come back for break. This 1 through 4 will be the homework set due for Sunday, this Sunday.
Thank you.
Sure. And you guys probably have, what, like 25 or 30 minutes here. I suspect if you were diligent, you could finish all 4 of these in that time. I would just get it done so that, like, it's one less thing to worry about and I can roll into break footloose and fancy free, you know? You never heard that saying?